Welcome to Module 17, Reliability. Let's start by talking about the module contents. As part of the basic topics, we will cover basic concepts, which include reliability, functionability, and durability, as well as failure analysis. Second, we will talk about fundamentals of reliability mathematics, including probability, data analysis, and distributions. Third, we'll see some reliability tools and techniques, including reliability, durability, failure function, mean time to failure, mean time between failures, reliability block diagrams, and reliability of systems connected in series or parallel. Then we will progress to some advanced topics, such as design for success, how to consider design for proper reliability, maintainability, supportability, and lifecycle cost. And finally, we will talk about management of reliability, which includes warranty, availability, reliability allocation, and reliability enhancement. So let's start with the first section of Module 17, which is basic concepts on reliability. So let's go and see some basic concepts. At the very beginning of this module, we will first try to put reliability in the right context. We all have an idea when we hear the term reliability or reliable, and we can easily relate this word with dependable, solid, credible, good performer, and so forth. And we will be about right with these definitions. The first consideration to keep in mind is that reliability is a design attribute. The level of reliability of a piece of machinery is defined, is established, is born when this piece of equipment is being conceived or designed. Other important aspect to keep in mind is that in our modern world, reliability by itself is not sufficient to have a system or a piece of machinery that can be considered truly dependable and technically effective. In order to have a dependable machinery system, it needs, of course, to be able to perform its required function, the reason why it was developed. But it also needs to be available, and this means it needs to be reliable, maintainable, and supportable. We'll be talking more about this in the course of this module with particular emphasis on reliability. So let's talk about systems. They can be as big as the universe or as small as a molecule or an atom. They appear in nature, but they are also man-made. Systems are composed of elements, their attributes, and the relationships among their parts. System, it's a relative term. It depends on what is being considered by the user, as we will see. A group of pumps in certain service can be considered a system, since they are completely integrated to perform a required function. A particular pump with its motor, casing, impeller, seals, bearings, etc., it's also a system. Furthermore, a mechanical sear with its static and rotating elements, springs, O-rings, gaskets, etc., can also be considered a system. Reliability can be established for individual components or complex array of components. We will see this later. Now let's talk about our main concept, reliability. The reliability of a system is the probability that the system under consideration will be capable of maintaining or performing the required functions for a certain period of time under certain stated conditions. You will notice in this definition certain words that are stressed or bold. First, reliability is a probability. As such, it's determined for the likelihood of happening and is based on statistics. Its value will be between 0 and 1. Second, require functions. The user specifies what are the minimum performance parameters to consider that a system is working in an acceptable manner. You need to keep in mind that what is acceptable for one user might be considered fail for another one. So this term is also a relative one. Then we have the word period. So reliability values change. They are related directly with time. Typically, when we are talking about reliability values, it needs to be associated with a specific time. Last but not least, conditions. Reliability is dependent on the operating conditions. If the conditions change, for example, ambient conditions, the reliability might be affected. There are various measures that are used to define reliability and their related parameters in a numerical, more comprehensive way. Again, these are used depending on the user needs and include parameters such as mean time to failure, mean time between failures, mean time between maintenance, mean time to repair, and so forth. So let's talk about a few more concepts. Man-made systems are conceived or created in order to perform certain function that satisfies a need. It is important to understand that it is not the system per se the one that satisfies the need, but the function it performs what really satisfies the user need. The functionality of the system can be defined as its capability to satisfy the need isolated from other factors, that is, by itself, by design, by its own nature, as built by the manufacturer. But in addition to the functionality, the user wants also the system to be able to provide certain levels of performance and to have certain attributes that are compatible with the specific application, and that the system is capable of performing well with these attributes in the user environment. This is the reason to introduce the term functionability, which is the inherent or defined during design ability of the system to perform the required function, providing the required performance and maintaining required system attributes when operated under certain conditions. For example, a pump. The functionability will include these factors. The functionality is the capacity of move liquid. The performance will be a certain user specified rate and head, and the attributes with certain corrosion resistance, for example. All this inside a defined environment. This is the functionability. The main difference between functionality and functionability is that the latter considers performance, attributes, and environment to define a system capable to satisfy a need. In a related definition, the period of time that a system maintains its functionability is known as the duration of the functionable life, or time to failure. So let's revisit the technical effectiveness of systems. Functionality alone is not sufficient to have a system or a machinery system that we can depend on. We say that a machinery system is technically effective when it's able to satisfy a need from the functionality point of view, but it also needs to be available. To be functionable, the system needs to be able to perform the required function with certain performance and attributes. To be available, the system needs to be reliable, maintainable, and supportable. We'll be talking in more detail about the reliable portion, but please keep in mind that the ability of the system to be maintained and the ability to receive adequate support, including logistics, is critical for the system in order to be available and therefore to have a system that is technically effective. Last comment is that please know that all these characteristics or potential to perform expected function with certain performance and attributes while being reliable, maintainable, and supportable are inherent characteristics that are established during the design stage.